All right, let's solve this initial value problem. First, we are going to attempt to separate the variables, which is not too difficult here. Once we write it in differential form, we see that we can pretty easily move the t's to the right and the y's to the left. So here is our separated differential equation. And at this stage, we are going to integrate both sides. So on the left, we end up with natural log absolute y plus 15. On the right, we end up with natural log absolute 7t plus 50. We have to divide by 7, though, because of the reverse chain rule. Now, in order to get an explicit solution, which is a preferable spot to get to, we are going to exponentiate both sides. And when we exponentiate both sides, let's write this as a coefficient of 1/7. Natural log absolute 7t plus 50 plus c. Now we can use our laws of exponents here to rewrite the right-hand side in a way that is going to put a c down in front. And this is helpful so that we can eliminate the absolute value on the left. So laws of exponents tell us that we have e raised to this power multiplied by e raised to this power. And e raised to the c is just another constant. And that's what this is. This constant right there is representing e to the c. Now that allows us to say that y plus 15, we can get rid of that absolute value bar because we can say that that plus or minus 1 is going to get absorbed into that c that's out in front. And then we subtract 15, and we now have our explicit solution. We've isolated y, which is always a goal. So there is our explicit solution. Plugging in the initial value, y is equal to 0 when t is equal to 2. So when t is equal to 2, we get 64 inside the absolute value bars, which is inside the natural log. Okay, let's solve for c here. So add 15 and divide by the exponential. Then we have this is our c value. And that allows us to write our final explicit solution to this initial value problem as y equals, so this is our constant out in front, multiplied by e to the 1/7 natural log absolute 7t plus 50. Not trivial, a little bit complicated there, one step at a time.